Hello, students, and welcome to this LumiKnow Tough Enough series where I solve IBDP and MYP questions, the past paper questions, right? Now, so today I am with one of the DP question. Now, this is the second question of DP. Last week I solved another question of last week I solved a question which was from May 2026, and this question is also from the year 2026, May 2026, right? So the time when I'm recording this video, May is just 2 months before, right? May was just 2 months before this, right? So now I'm recording this video, and now let us get into this question. This question is about thermal physics, phase change, and entropy. Totally, it is 8 marks. Okay, let's understand this question. A mass of 0.25 kg of ice and at the temperature of minus 32 degrees Celsius is placed in water at 0 degrees Celsius. Okay, now water is having 0 degrees Celsius, ice is having minus 32 degrees Celsius, and the mass of the ice is also given. When the thermal equilibrium is reached, the temperature is 0 degrees Celsius. The only transfer of thermal energy are between the ice and water. Okay, and the following data is available to you. You are given specific heat of ice, you are given the latent heat of fusion of ice. So basically understand the situation. Ice is kept inside the water, ice is very much cold, and water is at 0 degrees Celsius. So water is actually hotter than ice, I would say here. Though water is 0 degrees Celsius, water is hotter than ice. So because of which the ice warms up, increases in temperature, and reaches the equilibrium temperature, which is again 0 degrees Celsius. That means the water still stays as 0 degrees Celsius. So what has happened? Ice has melted. Okay, so that's why I have been given the latent heat of ice, which is 2100, and the specific latent heat of fusion of ice, which is 334 kilojoules. Now they're asking here, show that when thermal equilibrium is reached, about 50 grams of water has turned into ice. Okay, now what they're saying here is that when thermal equilibrium is reached, 50 gram of water has turned into ice. Water has turned into ice. So that means the so remember, we are at 0 degrees Celsius. Okay, the water is already at 0 degrees Celsius. It is the freezing point, melting point of, or I would say freezing point of water. When you're putting ice of minus 32, that is going to drop the temperature of water, and some of the water is going to turn into ice. Okay, and that is what I have to calculate right now. So now let me calculate the energy required to raise the temperature of ice from minus 32 to 0. So what is my energy required for ice? Okay, for ice to go from minus 32 to 0. So here I'm going to be using the specific heat capacity of ice. So Q is equal to mc delta T, where delta T is going to be 32, C value is given here, mass of ice is given to you. Okay, then when you plug in all the values, you are going to get somewhere around 1.68 into 10 power 4. If I do the calculation, 1.68 into 10 power 4 joules. Now this is the energy that comes to the ice, because ice is cooler. So this is the energy that goes to the ice for the conversion. Okay, now I will be using latent heat released by the freezing water. Now understand one thing, water is freezing to ice. So when the freezing process is happening, latent heat is coming to picture. Okay, now let me tell you, this energy, this particular energy is used to freeze water. So who gave this energy? Ice gave this energy. Why did this ice give the energy? To freeze the water. So now I will use the specific latent heat formula, which is nothing but the Q is equal to ml formula. And I want to find out what is the mass of water that has turned into ice. Plugging in the Q value as 1.68 at 10 power minus 10 power 4. Plugging the latent heat as 334 kilojoules. Okay, when I plug in those values, I will be getting somewhere around 50 grams. Okay, you will get this M value around 50 grams. Now see, I'm not doing the calculation and showing you here I want you to do the calculation independently. This video is not solving question. This video is just making it simpler for you to solve the question. Okay. So I'm just telling you the techniques that is required to reach your answer. Doing the calculation is in your hand, right? Okay. Now this question continues in the next page. Right. That means I have to go to the next page. Right. So next page gets me this. A student states that the internal energy of the water of 50 grams of water in the part A does not change when the mass turns into ice because the temperature is constant at 0 degrees Celsius. Discuss the statement. Now they are saying, this boy is saying that internal energy of 50 grams of water does not change because the temperature is not changing. Now student, let me tell you, temperature directly tells about the kinetic energy of the system, right? It directly tells you about the kinetic energy of system. And kinetic energy is not, and internal energy is sum of potential energy plus kinetic energy. Very good. Now the student might say it is not changing because temperature is not changing. So the student is thinking that when kinetic energy is not changing, sorry, when temperature is not changing, kinetic energy is not changing. But when kinetic energy is not changing, that doesn't mean internal energy is not changing because there is potential energy also. Yes, here the potential energy is changing because the water is turning into ice by molecules coming close together, and that is changing the potential energy. And when potential energy changes, obviously the internal energy is also changing. So that's why I can say that this statement is actually wrong. Okay. Next question. Calculate the decrease in the entropy of the water. Entropy is decreasing, and I need to find out how much is entropy decrease. Okay. Now the decrease in entropy is nothing but we have a formula. It's a very simple formula. Delta S is equal to delta Q by T. Simple formula. Delta S is equal to delta Q by T or Q by T. So you look here, I can find the Q value because my entropy is changing when the water is freezing. So what is the energy required for the water freezing? That's nothing but M into L, right? So that's my M into L. So I put my M as 50 grams, my L as 334 kilojoules, and the temperature here at which this is happening is somewhere around 273 Kelvin. So please do not put 0. Okay, put 273 Kelvin. If you put 0, your delta S is infinity. Okay, so delta S value is the change in energy of the system at what temperature the change is happening. So you know that when a state change is happening, that is when the entropy change is happening. The state change is happening at 273 degrees Celsius, obviously. And how much of heat energy exchange is happening? M into L of energy exchange is happening. You do this calculation and you will be approximately getting somewhere around 61 joules per Kelvin. The unit of entropy is joules per Kelvin. Joules on top, Kelvin on the bottom. Okay. Now finally, outline how the results of part B2 is consistent with the second law of thermodynamics. What does the second law of thermodynamics say? The second law of thermodynamics says that the total entropy of an isolated system not okay. So there is basically the total entropy cannot increase. The entropy always decreases during freezing. Okay, so you see here your entropy. Okay, so if this clearly tells you that decrease in entropy in the freezing of water is more compensated by the increase in entropy of the warming ice, hence total entropy increases. So here the total entropy of the system, the statement I'll write down, total entropy of the system increases, always increases. Total entropy of system, total entropy of total entropy of the system always increases. So look here, what is my entropy here? 62 joules, right? Oh, I just wrote 61. Oh, sorry, 61 joules here. Sorry, I just wrote 6. So you see here delta S is 61. So it's a positive number, right? It's a positive number. So what does it mean? The entropy of the system is increasing. So in this scenario where the freezing is happening, the entropy of the system is increasing in this situation. Okay, so that will be your answer in this given situation. Okay, students. So with that, this question is done. So comment and let me know if this question you found it difficult. And if you are a DP student and you are preparing for your upcoming examinations in future, please do follow this channel, like this video, and send it to your friends who are in DP. I am just going to solve DP and MYP questions and make it simple for you. That's my task in this particular channel. And every Friday, there will be a video where I'm solving the previous year questions. So with this, I will end this particular video. Next week, I'll come with another video and another questions of any MYP or DP related MYP past questions. So until then, bye. And I'll tell you later where you can find these questions for practice. I'm going to create a separate course for DP students where I will be uploading all these free resources for you. I'm working on that. As soon as it comes, you will start finding that in the description of my video. So with that, I will end the session. We will see in the next session or next week. Bye, students.